So welcome to this session about are your CI/CD pipelines secure? Our presenter today is Angel Rivera. Hope I said that right. Angel's career started in the US Air Force Space Systems Operations, and he's worked in private, public and the military sectors. So he's got experience in military space lift ops, technical writing, software dev, SRE and DevOps engineering. So he's very well qualified to talk about the common obstacles in securing our apps and pipelines. Over to you, Angel.
All right, thank you so much. Good afternoon to everyone. I'm in the U.S., just up New Jersey, just outside of Philadelphia. So it's a 20:30 on February 12th, so day behind in the evening for me. But super excited to come and speak to you all about securing pipelines. So let's see. Okay, great. So this is a quick agenda. I'm just going to do a little quick intro about myself and what it is that I do at CircleCI. Jump into talking about software development life cycles and how it relates to CI/CD. Then I'm going to talk about a little bit about DevSecOps and how that relates to your pipelines and integrations, and then securing those pipelines. And finally, a quick recap. So as I was introduced, my name is Angel Rivera. I'm a developer advocate for CircleCI. And essentially what I do, my role at CircleCI is basically engaging at a grassroots level, the developer community, and pretty much anyone in the technical industry or the technology industry. One of my main purposes is to understand how people are leveraging technology, how they're using it, how they're implementing it, how they're integrating it, how they're securing it, all those aspects, so that I can then bring some of that information back to our teams at CircleCI, and we can build, features and products that will add a lot of value to the community and our developers and our customers. So if anyone wants to reach out after the talk or after the conference, my Twitter handle is the best way to get a hold of me. So it's @punkdata. I'm open to speaking to everyone and anyone about almost all topics. So please feel free to reach out if you have any questions or comments or just want to have a chat. I'm super excited to engage. So please feel free. So before we get into all the cool things I want to talk about regarding security and pipelines, I wanted to kind of take a step back in time. I like to level set the audience because, everyone has different experiences. We all come from different walks of life. So I want to talk about a little bit about the history of software development as it pertains to software methodologies. So, software development practices back when I started, actually now it's a couple decades ago, but when I started, we had pretty much one software development methodology that was predominant, especially in the fields that I was working in, which was back in the United States Air Force. And I was actually working at Cape Canaveral Air Station where we were launching rockets, right? So that's kind of how I started off my career. And that methodology that we were using was basically called Waterfall. And it's called Waterfall for a reason. The main reason is Waterfall development practices basically requires you to, well, not requires you, but basically essentially enforces the fact that when you have software requirements and you need to distribute those to your software development teams, once they get to the point where they're in a project manager's hands and the tasks are distributed out to the actual development teams and the folks who are building and coding the application or the systems, it has a cascading kind of dependency to it, right? So when these tasks are distributed, they're distributed mainly in bulk in the waterfall development process. So that means, you're issuing these tasks to your development teams. The problem is that those tasks that are doled out to the software developers occasionally, or in most cases, are going to be dependent on the task before it. So if you're writing applications and the application, or the part of the application that you're writing has some central I would say functionality that other maybe components are dependent on, you can't continue writing software until that major critical component, the higher level component, is complete. So the way that's the waterfall development process is, it's very dependent on previous tasks being committed or completed, I should say. So again, it's a cascading, very dependent heavy type of methodology for developing software. And as you can imagine, it's pretty inefficient, right? And I can tell you that from experience, when I started, programming and using this methodology, I was very frustrated because, nothing hurts more than a developer than having to wait for another developer to finish something. And in some cases, you weren't allowed to even go and help because there was just, these kind of regulations or requirements. So, it's just a lot of inefficiency and very few ways to optimize. So that's what kind of waterfall is, right? So if you have that picture of, like a cascading, very dependent, heavy type of software development practice, you've got waterfall down in your brain. So what I want to talk about next is, though, we're developers, we're engineers, and towards the end of the 90s, beginning of the 2000s, I started learning about this new kind of methodology that was coming on the scene, which was kind of I don't want to say an upgrade, but it felt to me like an upgrade to Waterfall, which was the Agile Development methodology, right? And within the Agile Development methodology, what they devised or figured out was the tasks that were kind of interdependent, right, and kind of flowing up and down, cascading, could be broken out into smaller chunks. So if you look at the center of this diagram, you have, the people, I guess, symbols there. You have a Scrum Master, product owner, right, and then a nice little development army or development team there. And basically what happened was, again, we figured out that we can do many tasks at the same time if we just broke them apart into smaller chunks, right? So they're not dependent on things. And if you can look at this diagram, it's way different from the waterfall diagram. There's a lot of movement here, right? A lot of circles, a lot of items as far as, things that need to get accomplished within the project. And again, what we figured out was, we can do things concurrently and in parallel because those chunks and dependencies were kind of, diminished or eliminated altogether. So, it's just like anything when you're multitasking or multi-threading, or you're doing things concurrently, you can do multiple things at the same time, you become more efficient and obviously, right, get things done a hell of a lot quicker. So when we implemented these agile development processes, we also noticed that, right, we've gained a huge amount of efficiencies on the way we develop software, but we could do better, right? We could make things even more efficient. And that's where this concept of continuous delivery kind of crept up into onto the scene, following, the adoption of agile development practices. Now, continuous delivery gives you the ability to kind of take some of the manual labor that was going on in those software development practices, in the agile development practices, and enable you to automate that, right? So with continuous delivery, you can leverage, it's a practice, but you can leverage automation to get things done quicker. And from that, right, again, we're engineers, and when we started implementing these continuous delivery practices, we started to see other patterns, right? So that's where we saw other patterns that will help with the development process. And that's where continuous integration, continuous deployment kind of also was born from this continuous delivery practice. Now with continuous integration and continuous delivery, it really blends really nicely with DevOps concepts, right? So I'm pretty sure most of you have heard at least the term DevOps, but basically the way that continuous integration and continuous deployment ties into it is, if you look at this diagram here that I'm showing, the infinity loop is what I call it, the DevOps infinity loop. You can see where like the dev lobe is actually what I consider like the continuous integration tasks and bits that we all do as software developers. And if you focus in on the ops lobe, that's where the operations team kind of flows in, right? So conceptually, DevOps is more of a culture shift or adoption that you need to make within your team so that you can better, operate. Your developers and operators can better function on a team and gain some efficiencies in how, around the way they work and build code and deploy that code as well and maintain it. So with continuous integration, I just want to talk about some of the principles. And again, right, continuous integration tends to lean towards the development side of the house. But with continuous integration, some of the practices and principles are, you're going to be writing code and committing that code often. So you're collaborating, your teams are now collaborating in and around code. Then you're going to be committing those shared, or those code changes as often as possible to a shared repository where then, you can do things like test your code on every commit. And then my favorite aspect of the continuous integration principles are the fast feedback loops, right? Being able to understand and know when you have issues with your code. I can't tell you how impactful that is, right? To be able to know within a certain within minutes, like 5 to 10 minutes, that, hey, I have a bug in my code and I need to fix it, right? Before it goes down that continuous integration pipeline. So I talked about continuous integration. Now let's talk about continuous deployment in principle, right? Again, it kind of leans, for me, it leans more towards the operation side of the house. But basically, right, what we're doing there is creating, release artifacts to be deployed, and then developing a mechanism to actually deploy those applications, ensure that they're functioning, and also ensuring that the state of the application is being monitored. And hopefully it has a way to, or a resiliency type of functionality where it has a way to self-heal, recover, auto-recover from any kind of failure, which is more common these days. So all of those things I talked about, again, were in practice. But as I mentioned earlier, automation is what actually make those practices come to life, right? So, we can operate in a certain way when we're actually developing code. We can, and again, the CI/CD DevOps paradigm is all about culture and how humans are actually building code and interacting around the code. But again, you need that automation to actually implement things, right? To actually make those concepts and practices and principles come to life. And when you're leveraging that automation, we're talking about CI/CD pipelines, right? So when I talked about continuous delivery earlier, that's exactly what continuous delivery, one of the aspects of it is looking at things from a lens of a pipeline. So if you know anything about a pipeline, you have segments, right, that in your pipeline, because there's not one infinite piece of pipe right out there that can cover things. So you have to build things in segments. And so that's kind of like when you're building, using that automation to build software or to automate functionality in software, a pipeline has segments. And I'll get into that a little bit. I'll show you a diagram where you can see that. Actually, yeah, here it is right here. So basically this is what we call a CI/CD pipeline. And this is This is a pipeline represented in the CircleCI dashboard, which is the platform that from the company I work for. And as you can see, right, there's little blocks of things. And if you were to click on one of those blocks, you could see all of the tasks that actually occur, right, in these pipeline segments. And one of the things I wanted to point out here was, if you look to the left, you can see that there's like 3 tasks happening at the same time. And I don't know if you can see the lines, they're kind of light, but if you can see the lines that are connecting those, to the left, you have what we call concurrency build, jobs that are building concurrently. So again, right, if we talk about that agile methodology and doing things at the same time or concurrently, this is kind of, right, gives you a little bit of a picture of how that all works and fits together. So with those pipelines, right, and I'm sure you saw there was some of the jobs there that mentioned like creating a GKE Kubernetes cluster, you know, building and testing the code, all of those things, and okay, not all of them, but most of those things will require some sort of integration, right? Some sort of way to communicate with another service or another API. What I call those, when you're doing that, when you're connecting within your pipelines to another service to get things done, I call those there's an integration type, right? So depending on what type of service or external system you're connecting to, you know, and there's a bunch of them, right? So here's a nice little list of what I call pipeline integration types, right? So sometimes you're integrating a application code coverage tool, right, to do some static analysis. When you integrate, you can also be, you know, integrating a vulnerability scanning tool. Maybe your pipeline needs to connect, or one of your pipeline segments needs to connect to an API of some sort or service, right? There's many different types, but I just want to call out like some of the more common ones that we use, right, within the pipeline. So you can, you know, take action. Things that our developers used to do manually, right, to test their code is now being done using automation, using CI/CD pipelines and these integration types. So let's jump over now and talk about DevSecOps, right? So I gave you a little bit of an intro into DevOps, right? It's more of a cultural shift, right? The way people operate. I know that there are products out in the market with the DevOps kind of nomenclature attached to it. I can tell you that DevOps is, again, more about the people, the culture, right? And how software is being developed, not necessarily about a product. But I would say that, you know, when I started kind of adopting and learning more about DevOps, there was always security involved. And I don't know why or when the security aspect kind of fell out of the name. But I can tell you that from when I was starting to, you know, dabble and get familiar with DevOps, security has always been a part of that whole, you know, conversation. So I'm glad to see that the industry is now, you know, putting a little emphasis on it. And I think it's very appropriate, especially with all of the security incidents that we've been having lately and in the past as well. But with DevSecOps, right, all we're doing is, if you can picture that pipeline that I just showed you a few slides back, have that image in your head, and all those little blocks that represent the job. With DevSecOps, right, so what we're emphasizing there is that when security is kind of left to the right of the pipeline or the end of your CI/CD pipelines, right, which is, I have to say, still the case in the majority of the folks that I discuss these topics with. They're working at, you know, and it's mainly in the bigger companies these days. But what's happening is, right, a developer will develop some code. It'll go through the CI/CD process, maybe test. Then the developer will package it up into an artifact, Docker image or some sort, whatever that looks like in your industry. And then it'll push down to maybe an operations team member. And, you know, then before it's deployed, a security team member will come and do some sort of scanning. And if you're a developer and you've been down this road, you know that that never ends well, or hardly ever ends well, because once those security teams, right, they're not communicating with the developers, they're not really communicating with operations. Once they find vulnerabilities, right off the bat, they'll use a tool, and the tool will tell them how to mitigate. Oftentimes than not, the security team will try to upgrade or change the code at some point without ever consulting the developers. That's not, I'm not saying that happens all the time, but it's generally the experience that I hear about and I've experienced myself. We have this term now, though, called shifting left, right? So shifting security left. And all we're doing is taking that, those security actions that are being performed right before deployment, and we're shifting them to the front of that pipeline. So before I came on the scene as a developer, right, I didn't have the tooling or the knowledge, to be honest, to kind of understand security and how that all kind of played or integrated into my work. The way that I was, indoctrinated into the security schemes where when, there was pipeline failures at the end, and the security teams would come and say, hey, your code's broken, fix it. And they'll just throw a couple logs at me with some of the scan reports, right, the vulnerabilities. And then it was up to me to figure out what was going on. Over time, I developed, relationships and skills and all that good stuff to do that. But today, it's more exciting for developers because of all the new tools that are empowering developers to understand the security landscape a lot better and actually take action, right? I have yet to meet a developer that does not care about security, right, when it comes to their code. We definitely want to write secure code. We're all about it, but we don't have that, knowledge and the specific knowledge of security to be able to be, very efficient. Now with these tools, we actually have a lot of capabilities that enable us, right, to be empowered to now start taking action. And that's what we mean by shifting left, is now the developers can do things like scan software dependencies that we're using and try to detect any kind of vulnerability, right, before that stuff actually even gets packaged up into an artifact. So the developers right away can, using these new tools, can get a sense of what's going on as far as in regards to security, right? And what kind of vulnerabilities exist in the current software, and then take action. That way, the security teams don't go in and kind of shoehorn in their own fixes or whatever at the end, and then causes a bunch of problems and slows down that pipeline velocity, right? So the release cycle gets kind of battered and slowed down. So we're trying to keep things efficient, keep things moving and optimized. And again, right, by integrating your security actions into a pipeline, developers can kind of, take some of that workload off of your security teams at an earlier stage than they would have back in the day. So, right, some of the things that developers are doing now with the automation and the new tools are basically given the ability to create these pipelines that have jobs that do security scans. Another kind of concept area, app scanning, so static analysis, right, on the dependencies. There's a lot of cool tools out there now. Some are open source, some are not, some are like in that hybrid area. But at the end of the day, there's still something, right? You still have a mechanism to perform these security transactions as a developer. And right, the static analysis applications are really big. And also, since Docker and containers and Kubernetes is kind of dominating in the tech space, we also have the security tools now to enable us to scan containers, right? So not only are you scanning your code and checking for vulnerabilities and those dependencies that are vulnerable, you're also scanning the actual artifact, right? So the Docker image, if you're packaging that app into a container, those actually have even more vulnerability type risks, right? Because what you're doing is packaging up that code into a container, which actually has even more dependencies, right, outside of just your code. So there's like layers to how you're scanning and detecting things. And again, right, leveraging that automation within your CI/CD pipelines to do this. But yeah, all CI/CD pipelines and platforms, by the way, they have obstacles, right? So as developers, even with security, from a security perspective, we do have some obstacles still. And one of the things that I wanted to talk about in regards to securing pipelines is basically, when I talked about it a little bit earlier, was integrations, right? Integrating into different services, or integrating different services into your pipeline. So that means you have to access things. And when you have those integrations that require access, that basically means you need credentials, right? Or some sort of sensitive information to gain access to those things. And when you have that integration of access, or access integration, right? You have different kind of mechanisms that handle those credentials for you, right? Or the access. So one of the mechanisms is OAuth, right? Or straight up access keys. API tokens is another kind of credential, right? That's out there. And they go on and on to the basic username and password, right? So these are not new things to most of us, but I just wanted to call them out because when you're integrating, obviously, right, you're going to need access to a system that is external to what you're doing, or what of all your services, right? It's just, you need those credentials. So one of the obstacles is, managing secrets, those credentials. I'm going to use the term secrets here because it can be sensitive data too, right? That needs to be protected. So with those secrets, right, it's just giving you access to all these different systems that you need in your CI/CD pipelines to ensure that your code's being tested properly, and it also is functioning as intended, right? Especially if it's a distributed system, which is becoming more and more popular today, right? We need those secrets to be super protected and then gaining access to those systems. Right, if you have any kind of vulnerability within those pipelines, right, if anything's kind of, leaking, or you have a vulnerable a pipeline job or something, or runtime, you're going to have problems, right? And then that's just going to escalate into something that probably can be avoided.
Excuse me, Angel. Just want to check. We've got just a few minutes to go.
Okay, great. Yeah, I'm almost done. So we have, so some of the symptoms of, right, like obstacles are, especially when it comes to credentials, is people are not updating passwords or changing passwords on a regular basis, or they're using really, really weak secrets, right, to like gate their systems. Also, one of the things that is kind of indicative and relevant across all CI/CD platforms these days is unmasked or unencrypted secrets living in the runtime, right? So when you're deploying, implementing one of your CI/CD pipelines in an automated manner or an automated platform, they're going to need, when you come to a job to like create something or access a system, you're going to need secrets. In those runtimes, though, when you're running that code, the secrets are sitting in the host platform, encrypted at rest, and then they're also encrypted when they're in flight, right, into that new runtime where your code is actually being executed. They have to be unmasked and then used. That's a huge problem these days because those runtimes are, unencrypting things and unmasking things. And if a bad actor or someone who's not authorized gains access to that runtime, you're going to have a bad day, potentially have a bad day, right? And the exposure is basically there. So having said that, one of the ways you can prevent that in your CI/CD pipelines is by implementing a secrets management kind of approach. And one of the ways you can implement secrets management is by implementing the secrets management tooling, right? And this tooling is there to help you basically encapsulate all of your sensitive data in a protected service, so that if your pipelines require you to access any of those services using those integration credentials, the system will actually dole those out for you, right? So I'll be done here shortly. So one of the benefits is implementing the tooling. You'll be able to auto-generate strong random secrets, right? And then you'll also be able to auto-rotate those strong random secrets. I had a client that I spoke to. When I gave him, some information about this, we had a discussion. He told me he hadn't changed any secrets on one system in 5 years, and I was like, shocked, first of all. And then I asked him, well, why haven't you changed them? He said, well, I don't know what would break if I change those secrets. So, there's a little bit, obviously, more to his problem than most of us have. But if you can implement something like this, right, you won't have that problem, because you can set like time to live policies around those secrets, and then have an auto rotation where like they are automatically generated and then rotated out of your system, right? So, and again, when you implement one of those secrets management tools, you can also gain a lot of granular access controls, or gain insights into your access controls, right? Or who has access. So, they help with audits, compliancy, right? So if you're in a regulated space, there's probably a ton of compliance type things you need to check off the boxes. Access controls is definitely one of those. So you'll be able to revoke and also issue automatically, right, these credentials that are needed. So yeah, let's recap real quick on all this. I know there was a lot to take in, but basically CI/CD principles, right? Write and commit your code often, commit to a shared repository, test that code on every commit, and my favorite of all, you'll get that fast feedback loop, right, to know what's happening with your code. When it comes to continuous deployment, basically you're creating these release artifacts to deploy, and then you're deploying those applications or the artifacts to whatever target environment that application was written for. You're validating your apps and services and making sure they're functioning, and also monitoring the state of those services. And hopefully you have some auto healing, auto recovery type capabilities within those services. So for DevSecOps, right, we're shifting security left so that the developers are more empowered to help secure the code and make things more efficient, right, in that whole software development lifecycle. App scanning and container scanning can be integrated into your pipelines, and that again helps with the velocity of your release cycles, making sure that things are being done optimally, efficiently, and most of all, consistently. And then finally, right, securing your pipelines. If you don't already have one, I would suggest you implement a security management tool along with some policies. Also integrate those into your CI/CD pipelines so that you can, get the benefits of having strong random generated secrets and credentials, and also the ability to auto rotate and replace those secrets at your leisure within your pipelines. And I think that's it. Again, if anybody wants to reach out, my handle is punkdata.
Thank you very much, Angel. So we're out of time for questions, unfortunately. This is someone who's got a desperate question, needs it answered now. Otherwise, feel free to contact at punkdata.